This question gives us a function that's it's a quotient. So let me bring it down here. So we have f of x equals sorry about that. Tangent x minus 3 over secant x. Well, it takes time to get used to these kind of things, but one thing you want to do right away when you see two things over one thing is it's usually helpful to separate them like this and just say, okay, it's just tangent over secant and 3 over secant, right? That's just common denominator run backwards, right? Or you could just say, look, there's one big bar, the secant is dividing them both, so just make it two separate. Now, why is that helpful? Well, because notice I haven't done the derivative yet. I'm just cleaning up. What is tangent now? Do you remember tangent is sine over cosine? So you got to remember your trig rules here because this will help. This is going to become sine x over cosine x. And then what is secant? 1 over cosine. Do you remember secant is 1 over cosine? I'll write that up here. Tangent is sine over cosine, and secant is 1 over cosine. So get that minus, and then what are we going to do here? Similar. We'll put the 3, and again, this is 1 over cosine. Okay. Now, why is that so great? Well, because now I'm still unclear. I haven't done any derivatives yet. I'm going to remember when you have a fraction on the bottom fraction, you can just grab it and flip it up like that. So it'll become sine x over cosine x times cosine x over 1 minus, same thing here. Grab this guy, flip it up. You get 3 times cosine x over 1. Because why? Because dividing is upside down multiplying. I don't want that to be mysterious to you. Think about it. If I take 10 divided by 2, we all know that's 5. That's the same thing as 10 multiplied by a half, right? Half of 10 is 5 also. Do you see that how that proves that dividing by a number is the same as multiplying by the upside down of that number, isn't it? So dividing by a fraction is the same as multiplying by the upside down. Multiplying is just upside down dividing. Okay, now why is that? You might say, okay, well, great. So what? Well, you see what happens? These cosines cancel. And so this just becomes sine of x over 1, but there's no need to show the over 1, minus, and then this will be 3 cosine x. Again, you don't need to show the over 1. So now that I still haven't done the derivative. All of that is rewrite. Now finally, I'll take the derivative. So now I'll go, okay, now what is what is the derivative, which is what I was asked to do from the beginning, right? I did all that rewrite. From the beginning, they said, or they said find f prime. So before I did f prime, I did a whole bunch of rewrite. How did I know I was supposed to do that? Well, when you have two things over one thing, just one big bar. They're both divided by secant, and then write them as sines and cosines, and flip that guy up, cancels. So now it's an easy derivative. What's the derivative of sine? That's easy. That's cosine. What's the derivative of cosine? That's negative sine. The derivative of all co-functions are negative. And so what is that then? Just cleaning that up a little bit. It's cosine x plus 3 sine x, right? Because negative times negative is positive. So there's the derivative. Very easy derivative after we did that nice cleanup. And last step is they want you to take that and plug in a 1, right? See it up there? Plug in a 1, f prime of 1. So now we go, okay, that's not hard. F prime of 1 equals, we're literally just going to plug a 1 in there, plug a 1 there, make sure you're in radian mode. Go to the Desmos calculator or whatever calculator, but we're always in radian mode unless in calculus when we're dealing with trig functions, unless they specifically say degrees. So it's radian mode, plug it in, hit the buttons. I guess you'll get that number. And so there we go.